this is h of k, which is nothing but u of k. So it is starting from 0 up to the infinity. It will be there here. So that is 0, 1, 2, 3. So it is having the amplitude 1 will be there. So this is h of k. Next, I'm going to plot h of n plus k. I'm going to plot here. N plus k is nothing but the signal will be shifted towards the left side by n units. It is going to be shifted here. So like this, it will be there. So this is h of k plus n here. So this is nothing but minus n, and this is the time index called k. Okay, this is the time index called k here. So it is amplitude will be equal to the 1 will be there. Its amplitude is 1. Okay, next let us take the reflection. When you take the reflection here, the sequence will become something like this. So this is h of k minus n, sorry, minus k plus n. This is nothing but h of n minus k. N minus k. So this is nothing but the signal will be starting from n. So we don't know what's the value of n here. So it will be like this. It will be there here. So this is n. So it will be a positive value till the minus k, till the plus k. It will be there. So this is not exactly origin. So this is a h of n minus k. We are going to denote here h of n minus k. Okay. So in the meantime, we need to write the waveform called u of minus k. Also, we need to write here. So I'm going to write the waveform for the u of minus k here. U of minus k. So I'm not going to write for the 2 to the power of k. 2 to the power of k, we are going to substitute in the formula. I'll write the waveform for the u of minus k. I'll write here. Okay. So u of k is nothing but it is going to be like this here. U of minus k means the signal will be shifted towards the negative side. It will be shifted here. Negative side it will be shifted. Then. So this is h of n minus k. Now I am going to plot the waveform for the u of minus k. I will plot here u of minus k. So u of minus k is nothing but. So this is u of minus k. So plus k is it is going to start from 0 up to the infinity. Minus k is nothing but it will be starting from minus 0, minus 1, minus 2, minus 3 up to the minus infinity. It will be there here minus infinity. So it's having the value 1 will be there. It's having the value 1. So we are going to check up to the minus infinity. It will be there here. Then this is u of minus k. I've taken the part of this waveform I have taken here. Part of u of minus k, x of k I have taken here. U of minus k. Then next we have the waveform h of n minus k we have here. H of n minus k. I'm going to plot it here. H of n minus k I'm going to plot here. So this is h of n minus k. Okay. So it is going to start from n up to the minus infinity. It will be there here. Minus k. This is n. Somewhere like this, it will be there here. Okay. Then. Okay, fine. So this is u of minus k, and this is h of n minus k. Now, can you tell me what are the cases we can take here? Case 1. Can you tell me what are the different cases we can take here? What is the first case we can take? What is the first case we can take here? Case 1. So in the previous one, since both are positive sided sequence was there, the case was different here. Now here it is also negative. Here this one is also negative here. So what is the possible case we can take? What is the possible case we can take here? So here this is going to n is going to extend from till the minus infinity. It is going to extend, and this will be defined from 0 to the minus infinity. It will be defined here. So this is minus infinity. It will be defined. The first case we can take is n can take the value less than. So here also it is minus infinity. It is there here. So it can take the value less than or equal to the 0. We can take here. So n can take the value less than or equal to 0. We can take here. So first one itself, you are going to get the overlapping region. You are going to get here. So based on the waveforms, we need to take the condition for the n. We're supposed to take it here. Okay. So n is greater than or equal to the 0. We can take here. N is greater than or equal to 0. The first case is n is less than or equal to 0, not greater than or equal to 0. Less than or equal to 0 is supposed to take here. So n can take the any value between the minus infinity up to 0. Any value it can take here. Okay. So when n is less than or equal to 0, it will take here. I'm going to draw the waveform. This is the simplest case I can write here. This is u of minus k, and this is h of n minus k. When I take the product of this one, assume that n can take the value less than something called 0. So I can take the value somewhere here. So when you take the product of this one, that's the simplest waveform here. So here no waveform. Here assume that the waveforms will be there here. So 0 multiply with something, we will get 0, and we are going to get the waveform from minus infinity up to the n. We are going to get here minus infinity up to the n. We are going to get here. So the waveform is going to exist up to the minus infinity up to the n will get here. So this is minus infinity up to the n here. You're getting the concept now? Concept in this case. You're getting the concept, right? So n is taking the value less than or equal to 0. Less than or equal to 0 means I'm taking the value, assume that it is less than 0 only. Okay, so n will be getting overlapped with any of the value. So from n up to n after to 0, there is no waveforms here. So the overlapping will take place from minus infinity up to the n, it will take here. Minus infinity up to the n here. So we can say that the product of u of minus k and h of n minus k. So this will be equal to 1 because these are having the amplitude 1 from where. So from minus infinity is less than k is less than or equal to the n, it will be 1 here. Okay, so getting it right? Your concept. Getting the concept right? So from minus infinity up to the n, it is having the value 1 will be there, so that I can write so y of n. So this will be equal to the summation can take the value from k is equal to minus infinity up to the n, minus infinity up to the n. So we have in the summation we have that is 2 to the power of k into u of minus k into this one is the h of n minus k. So this will become 2 to the power of k into the remaining quantity, which is nothing but u of minus k into h of n minus k. So this one I can write as summation. Okay, so just here I'll write infinity. So afterwards I'll change the limit accordingly. K is equal to minus infinity to plus infinity. The product of this one is 1 here. So that's why I change the limits here. Okay, that's why I change the limits here. So it is 1, 2 to the power of minus k into 1 will get here. 2 to the power of minus k into 1, sorry, plus k into 1. Correct now, 2 to the power of plus k, right? Yeah, 2 to the power of plus k into 1 will get here. So I'll rewrite here. So y of n is equal to summation k can take the value minus infinity up to the n, minus infinity up to the n, 2 to the power of k will get here. Any doubts? Any doubts in this one?
No, sir.
Okay. Okay, fine. So k can take the value from minus infinity up to the n will take here. So now we have the formula for the sum of finite times formula. Sum of infinite times formula is it? The formula is, so we have summation n is equal to 0 to infinity, n is equal to 0 to infinity, a to the power of n is a. So this can be written as 1 divided by 1 minus a we can write, provided a should be less than 1 here. A should be less than 1. Okay, so here we have the formula like this. And here we have another kind of formula, the extended version, that is summation n is equal to n naught to the infinity, a to the power of n is equal to n naught to the infinity, a to the power of n. We have the other kind of formula. So this formula we can write as, so this can be written as a to the power of minus n naught into 1 divided by 1 minus a we can write here. So can we write? I think I have given this formulas in the first chapter. I have given the formulas. Okay. So done, right? So can we write like this? A to the power of minus n naught divided by 1 minus a we can write here. A to the power minus n naught into 1 minus a we can write. So these are the set of other kind of formula we can obtain here. Okay. Done. This formula correct now? This formula is correct, right? Any doubts with the formula? Any doubts in the formula?
No, sir.
Okay, so just cross checking. A to the power of, okay, so we have, now we can substitute the same formula, we can substitute here. And so what we need to change is, we need to change the limits, we need to change here. Okay. Okay, fine. So formula is there. So what we need to change is we need to, so here since we don't have any formula from this one, minus infinity to the n, we don't have any formula. That's why I'm going to change the n to the minus n. I'm going to change k to the minus k. I'm going to change here. So I'm going to change the k to the minus k. I'm going to change here k to the minus k. So if you change the k to the minus k, you can take change k to minus k. Change k to minus k here. So if you change k to the minus k, so this will become, so y of n will become, so k is equal to summation, k is equal to, this will become plus infinity, this will become minus n. So this will become 2 to the power of minus k will get here, 2 to the power of minus k. So this one we can rewrite this one as, so y of n is equal to, so since the summation can be taken in any order, so k is equal to minus n up to the infinity. So 1 by 2 to the power of k we can take here, 1 by 2 to the power of k. So then we can apply this formula. So here the value of a should be less than the 1 will be there here. The value of a is less than 1. So it is going to suit this one also, it is going to be suited here. Right? Done, right? Any doubts in this one?
So it is not clear, sir.
Video is not clear? Okay.
Yes, sir.
Okay, fine. So yeah, now it's okay. Yeah, now it's okay, I guess. K is equal to minus n, 1 by 2 to the power of k will get here. Okay, so the better thing, instead of if you don't remember this formula, the better thing what we can do it is, this. So we have changed the k to the minus k, we have changed here. K is equal to minus k, we have changed here. So what shall we do is, so here we have, okay, so just I'll rewrite the formula. Summation k is equal to minus n up to the infinity. So it is a 0.5 to the power of k is a 0.5 to the power of k. So if you not remember the formula, so we have the formula, assume that we have the formula summation n is equal to 0 to infinity. So a to the power of n is equal to 1 by 1 minus a. We have this formula. Let us convert this in the form of like this here. So what we can do is, let us substitute k plus n is equal to something called L. Let us substitute here. K plus n is equal to something L here. So I'm going to send minus n this side. So then it will become k plus n here. So this k plus n is equal to L. We are going to substitute here, L here. So that when k is equal to n, let us find out the limits of the summation here. So I'm telling, if this formula, if you're not going to remember, and if you know this formula, and I'm telling how to obtain the formula here. So what I am doing is, I'm substituting k plus n is equal to L here. How I taken as k plus n is, I send the minus n to this side, I sent here. So this has become k plus n to L here. So when k is equal to n, let us find out the limits here. When k is equal to minus n, so L will become equal to the 0. That's what it is going to satisfy the lower limit here. Okay. So similarly, when k is equal to the infinity, so L will also become equal to the infinity will get here. L will also become equal to infinity will get here. Okay. So L will also become equal to the infinity. So, okay. So video clarity is okay, I guess. You can able to see. So k plus n is equal to L. I am substituting. This is k plus n. Okay. And this is k is equal to, when k is equal to minus n, L will become equal to 0. And when k is equal to infinity, L will also become equal to the infinity will get here, infinity. Now what I am doing is, we need to find the value of k here. So k will become equal to the, so from this one, k will become equal to the L minus n will get here, L minus n. Let us substitute everything in this summation here. So it has become y of n is equal to summation. L can take the value 0 to the infinity, 0 to the infinity. So it is a 0.5 to the power of, in place of k, I can substitute as L minus n, I can substitute here, L minus n. So it will become, so since the summation is not a function of n, I can take this one as 0.5 to the power of minus n, okay, into summation. L can take the value 0 to the infinity into 0.5 to the power of L, I can take 0.5 to the power of L. So right, so this will become equal to, so 0.5 to the power of minus n, we can write as 1 by 5, 1 by 0.5, which is nothing but 2 to the power of n will get here. And this summation, let us apply since the value of a is less than 0. So 1 divided by 1 minus 0.5. So this is nothing but 1 divided by, so 2 to the power of n, 2 to the power of n divided by 1 minus 0.5 is 0.5. So this has become y of n is equal to, so it is 2 into 2 to the power of n. For the value of n can take the value, that is minus infinity, is less than n, is less than or equal to 0, it will take there, less than or equal to 0. So this is the value of n can take, for less than or equal to 0, it will take here. So right, n can take the value less than or equal to 0. So this values it will take here. Any doubts? Understood now? So this is the first case we find here. First case we find here. Second case we need to find out here. Done. Any doubts? Okay, now let us take the second case. Let us take here. Okay, let us take the second case here. The second case is, so we have taken the first case, n is less than or equal to 0, we have taken. So I taken the value less than or equal to 0. Next value what we can take is n is greater than or equal to 0 we can take here. Case that take the next case as n is greater than or equal to 0. So you can take case 2. Case 2 let us take here. Getting everyone? Any doubts? So these linear conversion problems are very, very important. So understand clearly, listen to my words, understand clearly. Okay. So then you practice the problems. So don't switch on the mobile and don't leave that one for the attendance sake. Okay. So attendance is okay, somewhat you'll get here, but getting the knowledge is very important. These problems you can't able to solve. Okay. If you understand in the class, it will become easy for you people to solve. Otherwise, it's difficult for you. So take the case 2, I'll take here. Case 2, the case is that, so n is greater than 0, I'm going to take here. Not equal to 0, it is greater than 0. So I'm going to plot the waveform for the u of minus k, I'm going to plot here. I'm going to plot the waveform for the u of minus k. Okay, I'm going to plot the waveform for the u of minus k. So u of minus k, this one only. So it will be there. So this is u of minus k. So it is going to start from n is equal to 0, 1, 2 up to the infinity. So 0, minus 1, minus 2 up to the infinity, minus infinity it will be there. So it is having the value 1. Next, I'm going to take the value of this one, h of n minus k. So here it can take the value, n can take the value greater than 1 here, greater than 0. So this is h of n minus k. So I'm going to take the value, n is greater than 1, like this. So this is n, so this is 0. So it will greater than that one, it will take here. Okay, so done. So right. Ashok, can you tell me what will be the product now? Ashok C. Ashok C, are you there? Ashok? Are you there, Ashok? Anybody can tell me what is the product you are going to get here? What's the product you'll get? Hmm?
1, sir.
One from where to where?
Minus infinity to 0.
Very good, excellent. So from minus infinity to the 0, we'll get as 1, we'll get here. Okay. So done. Okay, so when you take the product will be equal to, so from 0 to the minus infinity. So that is the u of minus k into h of n minus k. So this will be equal to the, so 1 from minus infinity up to the 0 here. So you can see the video, right? Clarity is there in the video. Clarity is there in the video, right? It's there, right?
Yes, sir.
Is it okay? Okay. So from minus infinity to 0 to the minus infinity is 1. So I can take u of minus k into h of n minus k. So this will be equal to 1 from minus infinity is less than n, sorry, is less than k is less than or equal to 0. So less than or equal to 0. So this will be having the value 1 will be there here. This will be having the value 1 will be there. Okay. So now, okay, we can do substitute here the expression for the y of n. So y of n is equal to summation k is equal to minus infinity up to the 0. So it is, so I'll write the generalized formula first here. So that is u of, that is 2 to the power of k into u of minus k into h of n minus k. So this will become, I change the limits accordingly. So summation k is equal to minus infinity up to the 0, minus infinity up to the 0. So I think video clarity is going down. So 2 to the power of k. Now you change the limits, k to the minus k, you can change it here and you can do it here. So by the time I log out and log in back, you tell me the answer what you will get here. Do it fast. Just I log out and log in. summation k is equal to minus infinity to the 0, 2 to the power of k. Okay, so 2 to the power of k we got here, 2 to the power of k. I'll change k to the minus k will change here. So change k to the minus k. So if you change k to the minus k, okay, so what you'll be getting is, so this will become y of n is equal to summation k is equal to the plus infinity up to the 0. So 2 to the power of minus k will get. So this one we can write as summation k is equal to 0 to the infinity, 0 to the infinity. So 1 by 2 is nothing but 0.5 to the power of k will get here. So minus k we can write as 0.5 to the power of k. Okay, and we know the sum of finite terms formula, we know it here. Sum of finite terms formula. So as per that one, so we can write this one as 1 divided by 1 minus 0.5. So this will become equal to 0.5 will get here. So this is for the value n is greater than 0. Okay, so let us relate here. So y of n is equal to for n is less than 0, it is 2 into 2 to the power of n. For n is less than or equal to 0, and this will be equal to the 0.5 for n is greater than 0 here. For n is greater than 0, it will become equal to the 0.5 we can write here. Then
Sir, for n greater 2, no, sir.
Okay, sorry. Okay, 1 by 0.5 is 2 you'll get here. Sorry. 2. So 1 by 0.5 is 2. Very good. Yeah. So 2 will get here. Done. Any doubts? Done, right? Okay. Let us take next kind of problem. Okay, so take the problem. Problem number 12. I think problem number 13, I guess. Take the problem number 13. Find. So take the problem number 13. So find y of n is equal to x of n convolution with h of n. So given x of n is equal to alpha to the power of n into u of n, and h of n is equal to, okay, so beta to the power of minus n into u of minus n. We have seen the formula problem for the alpha to the power of n and beta to the power of plus n we have seen here. Now let us take the formula for the reverse one here. So alpha to the power of n and beta to the power of minus n into u of minus n. Beta to the power of n into u of n into u of minus n. Let us find the formula here. Okay. So done. Now let us write the formula. The simplest one is this one. Let us introduce a shift in this one here. Let us introduce a shift in this one. So let us take y of n is equal to h of n convolution with x of n here. Always in the simplest one, let us do the introduce the shift here. So it will become summation k is equal to minus infinity plus infinity. So it is h of k into x of n minus k. H of k into x of n minus k. Let us take this one. Okay, so h of k is nothing but we have h of n here. H of k will become so beta to the power of minus n into u of minus k. So beta to the power of minus k into u of minus k. And similarly, x of k is nothing but alpha to the power of k into u of k. Alpha to the power of k into u of k. So right. And we want x of n minus k. X of n minus k is nothing but alpha to the power of n minus k into u of n minus k. Alpha to the power of n minus k into u of n minus k. Okay. So right now I'll take the only these terms I'm going to take here. The u of terms, u of the unit step function terms I'm going to take here, and I'm going to keep alpha terms there only, so that the product can become easily we can do it here. Easily we can do the product here. So first one is h of k. So which consists of the u of minus k is there. U of minus k is nothing but the waveform can take the value. So from k is equal to minus 0 to the minus infinity, it will take here. So that is u of minus k. So u of minus k, it can take the value from k is equal to 0, 1, 2. Okay, so up to the minus infinity, it will take the value. So this is nothing but minus k. This is u of minus k will get here. Right. And also u of n minus k we know. So this is nothing but it can take the value from already we are done the u of n minus k already we are done here. So straight away I'm going to write this one. So u of n minus k is nothing but u of k. First u of n plus k is it will be shifted towards the n elements. When you take the reflection, so this will become u of n minus k. It will become like this here. Okay, so this is n and this is minus k. We'll get u of n minus k. The value will become equal to 1. We'll get here. Done. So u of n minus k already we have done many times. So that's why I written u of n minus k directly here. Any doubts in this one? Any doubts in this one? U of n minus k. Okay, no doubts, I guess. Any doubts, anyone? No doubts, no? Is it audible? Can you hear me, my voice?
Sir.
Yes, sir.
Okay, fine. So now what is the first case? So we are taking the product of u of n minus k with the u of minus k we are going to take, and we are going to keep these terms like that only we'll keep here, so that the problem can be done solved easily without any confusion in plotting the waveforms. What is the first condition? It is similar to the previous problem. What is the first condition? Case 1. Can anybody tell me what is the case 1?
N less than or equal to 0.
Yeah, very good. So when n is less than or equal to 0, we'll take here. N is less than or equal to 0. So when n is less than or equal to 0, when you take the product like this, the product of this one, u of minus k into u of n minus k. So this is going to lie from n to the minus infinity, it will exist here. So n up to the minus infinity, it is going to take place here. So this is k and this is minus k. The product will be equal to the 1 we'll get. So that is u of minus k into u of n minus k. So this will become equal to 1 from minus infinity is less than k is less than or equal to the n here. Okay, and 0 otherwise here. So right now I'm going to substitute in the summation. So y of n is equal to, I'm going to write the summation. The summation k is equal to minus infinity plus infinity. So we have h of k. H of k is nothing but so beta to the power of minus k. U of minus k is there. So let us write u of minus k into h of n minus x of n minus k. That is called alpha to the power of n minus k into u of n minus k. U of n minus k. So we know that the product of u of minus k into u of n minus k is, yeah, tell me. It is 1 from minus infinity up to the n here. So the product of this one will make it as summation k is equal to minus infinity up to the n. Okay, so these terms product is 1. The remaining terms will become b to the power of minus k into alpha to the power of n minus k will get here. Alpha to the power of n minus k. So right, alpha to the power of n minus k. So here, since n is not a function of summation, n is not a function of summation here. So what we can write is, I can take alpha to the power of n outside the summation. The remaining part is summation k can take the value minus infinity up to the n, minus infinity up to the n. So alpha to the power of minus k, beta to the power of minus k will get here. So this can be written as alpha into beta whole to the power of minus k we can write. Can we write this one? Alpha to the power of minus k into beta to the power of minus k, here minus k, here minus k. So take the minus common here, minus k common, we can write alpha beta to the power of minus k will get here. Is it okay? Can we write like this?
Yes, sir.
Okay, fine. Okay, now what shall we do is, we'll change the k to the minus k, we'll change here because we don't have any formula which is going to suggest this one. So we're going to change k to the minus k. So you can check here, change k to the minus k, change k to the minus k in the above summation, change k to minus k in the above summation. Okay, when you change that one, so y of n will become, so alpha to the power of n, so alpha to the power of n, right? So alpha to the power of n will remain same like that only. So alpha to the power of n summation we have, so it will become k is equal to plus infinity up to the minus n will get here. So alpha beta to the power of plus k will get here. So since we have minus k, since we have minus k, so that will become equal to the plus k will get here, alpha beta to the power of plus k. And also it is, you know that, so the alpha is less than 1 and even the beta is also less than 1 is there here. Alpha and beta both are having the value less than 1 is there. Okay, so now we can check the summation, that is interchange the limits of the summation here, because in the summation we can easily interchange without changing any sign here. So it is minus n to the infinity alpha beta to the power of k, alpha beta to the power of k. We can write it here, alpha beta to the power of k. Then alpha beta to the power of k we can write here. So then, so what we can do is, so already we know this one. So this is k can take the value minus n to infinity. Already we in the previous problem we derived the formula here. So you can take, we know that summation. Okay, so n is equal to minus n naught to the infinity. N is equal to minus n naught to the infinity. Okay, something called a to the power of n. So this will be written as a to the power of, so minus n naught. Sorry, this is a plus only, let us take here, a to the power of minus n naught. Correct now? This is the formula, right? This is the formula,
Yes,
right?
sir.
A to the power of minus n naught into 1 divided by 1 minus a. Done. Let us substitute here. So it has become y of n is equal to alpha to the power of n into, so it is alpha beta to the power of minus into minus n naught will get now. Correct? Is it plus n or minus n? What will get? What's the formula we have seen in the last problem?
Minus n naught.
Okay, a to the power of minus n naught. So this will become minus of minus n. It will become plus n will get now. Minus of minus n plus n will get now. Correct now? Is it correct?
Yes, sir. Yes,
Okay.
sir.
1 divided by 1 minus alpha into beta will get here. So this has become alpha to the power of n into alpha to the power of plus n into beta to the power of plus n. So 1 divided by 1 minus alpha into beta will get here. So y of n. So we can rewrite this one as, this is from minus infinity, e less than n, e less than or equal to 0. So let us rewrite y of n is equal to alpha to the power of n, alpha to the power of n is alpha to the power of 2n into beta to the power of n. So 1 divided by 1 minus alpha into beta. Is it correct? It's correct now? It's correct, right? Okay. So similarly, let us repeat for the next case here. So can you do the next case here? Can you do the next case? The next case is nothing but, so n can take the value greater than or equal to 0, it will take here. So take case 2. Okay, n is take the value greater than 0. When n takes the value greater than 0, the waveforms is here. So n can take the greater than 0. So this will be taking greater than 0. So I can write. So this is u of minus k. So it is starting from 0 up to minus infinity, it will be there. So this is k, and this is u of n minus k. So it is going to take the value, n can take the value greater than 0 here. Okay, so like this it will take here. So this is u of n minus k. U of n minus k. When you take the product of this one, the product is going to exist between the, so this is a product of u of minus k into u of n minus k. So the product is going to exist from, okay, so 0 up to the minus infinity, it will exist here. So I can write for n is greater than 0, u of minus k into u of n minus k, this will become equal to 1. So from minus infinity is less than, okay, k can take the value is less than 0, less than or equal to 0, and 0 otherwise, 0 otherwise. Done. Let us substitute back in the summation, evaluate the summation. Okay, so let us substitute back in the summation here. So y of n is equal to, we have the summation summation k is equal to minus infinity to the plus infinity. So that is alpha to the power of minus k. Sorry, correct now? So that is alpha to the power of minus k. Yeah, sorry, beta to the power of minus k here. Beta to the power of minus k into alpha to the power of n minus k. Okay, into u of minus k and u of n minus k. So we can change the limit from k is equal to minus infinity up to the 0. So this product is 1. So it will become beta to the power of minus k into alpha to the power of n minus k. So alpha to the power of n minus k we can write as alpha to the power of k into alpha to the power of minus k. Okay, we can take that one outside. So summation will become alpha to the power of n. Summation k is equal to minus infinity up to the 0. So it will become alpha beta all to the power of minus k will get here. It is similar to the previous problem. So then now what shall we do? So this is y of n. So replace k by minus k because we don't have any formula. Replace k by minus k. So y of n will become alpha to the power of n. Summation k will become equal to plus infinity up to the 0. Alpha by beta to the power of k will get. So we can rewrite the summation alpha to the power of n into summation k is equal to 0 to infinity alpha beta to the power of k. This is as we can write as 1 minus alpha beta. So y of n we got this one. So for n is greater than 0. Okay, so let us summarize the value of y of n. So this is y of n is equal to alpha to the power of n by 1 minus alpha into beta for n is greater than 0. And for n is less than 0, less than or equal to 0, we got